Okay, here we want to use implicit differentiation, but we also want to be able to utilize the chain rule and the product rule within implicit differentiation. So let's just check this out. So first, let's just go with the rules, which we always have to remember. The first thing we want to always do is find the derivative of each term on both sides of the equation. Now, I underline each term because one of the most common mistakes that we make is we find the derivative on the left side, but we fail to find the derivative on the right side, and it costs us down the road. The second thing we want to do is each time we find the derivative of a y term, we write dy over dx. Now, in some of my earlier videos and when we take the class, sometimes we write y prime, but remember, that's interchangeable. The third thing we want to do is isolate and solve for dy dx, and that gives us our final answer. So let's just look at this one. Let's look at example 1. Let's just say x cubed plus 2 sine 5y, which is equal to 7x minus 4. Okay, so the first thing we want to do, we want to find the derivative of each term on both sides. So now, this is going to be 3x squared, and we have to be careful here on this next one because this is utilizing the chain rule. So remember, we have to bring the 5 out in front and multiply it by that 2, and the derivative of sine is going to be cosine. So 5 times 2 is 10. This is going to be cosine 5y. And each time we find the derivative of a y term, remember we had to write dy over dx. Moving to the right side, the derivative of 7x is 7. And the derivative of negative 4 is 0. Remember, it was a constant. Now we want to solve for dy over dx. So here we simply take 10 cosine 5y dy over dx. And that's equal to 7 minus 3x squared. Remember, we moved the 3x squared to the other side. And last, we want to solve for dy over dx. So to do this, we're just going to divide both sides. By 10 cosine 5y. Alright, we want to divide both sides here. That cancels. So our final answer gives us dy over dx is equal to 7 minus 3x squared over 10 cosine 5y. Alright, so now let's look at another example where we would have to use the product rule, but we use the product rule within the chain rule. All right, so like we said, we can use both rules together with each other. Okay, so here we're going to say x squared times y cubed is equal to, let's just say 4 minus 5y squared. It's just random. So the first thing we need to do is we need to use the product rule. Now remember what the product rule says. First times the derivative of the second term plus the second term times the derivative of the first term. So let's write this out. We're going to have the first term, which is x squared, and the derivative of the second term. The derivative of y cubed is 3y squared. It's a y term, so that's dy over dx. Plus the second term, y cubed, times the derivative of the first term, which is 2x. Let's move to the right side of the equation. The derivative of 4 is just 0. That's a constant. And the derivative of negative 5 squared is negative 10y. It's a y term. So we must remember that dy over dx. Now, this is a mistake that sometimes we make. Don't move too fast. Make sure we go through and we simplify everything and clean this problem up. And it just makes it a lot easier and a lot cleaner for us. So, of course, x squared times 3y squared, we want to bring our coefficient out front. So that's 3x squared y squared dy dx plus 2x y cubed is equal to negative 10y dy dx. Now, anytime we solve these problems, remember, in order to solve for dy over dx, first we need them on both sides of our equation. So let's do that, and we're just slowly breaking this problem down. And we move the 2x cubed to the right side. Okay, we brought the negative 10y. Now, in this case, we need to factor out the dy over dx. Remember, our whole goal, we're trying to isolate it. So that's going to be 3x squared y squared plus 10 is equal to negative 2x y cubed. And in the end, we have this problem. I'm going to do this to save room. To get dy over dx by itself, we have to divide both sides by 3x squared y squared plus 10. So we're going to say dy over dx, and that's equal to negative 2x y cubed divided by 3x squared y squared plus 10. So these are just two cases. Remember, once we get into implicit differentiation, that doesn't mean that we just forget about the product rule or we forget about the chain rule. We can use these in conjunction with each other. So here are just two examples of where we use them all together in conjunction with each other.